Next, we're going to use the theory-based inference applet, and we're going to find not only the 95% confidence interval, but 90% and 99% as well. So remember that our 2SD method is only to find a 95% interval. So I've put some screenshots here. You should go to the applet, and the scenario 1 proportion will already be there. That's the default. Then you're going to put in 1001 for n. You can not really see the 1 in there. And then you're going to put in for p hat the 0.53 sample proportion. And then when you click out of that, the count of 531 will come in automatically. Then you're going to go over to the right-hand side of the applet and check the confidence interval box and put in the confidence level of 90%. So the default is to have 95% there, but you can change it to 90% and then click on Calculate Confidence Interval, Calculate CI, and you should come up with the 0.5045 up to 0.5564 interval. Then you can change the confidence level to 95% and click on Calculate, and then you can change it to 99% and click on Calculate, and you should see the intervals that I have in the table under the under the confidence interval row. Okay, now another thing, just again by way of reminder, when we have a confidence level, we have a corresponding significance level, so let's just practice finding that. If my confidence level is 90%, then my significance level, which I designate with the symbol alpha, the Greek letter alpha, is 10%, but significance levels we write as decimals, so that would be 0.1. If my confidence level is 95%, then the corresponding significance level is 5%, which again as a decimal is 0.05. And if my confidence level is 95%, then the corresponding significance level is 1%, which as a decimal is 0.01. All right, now what I want us to do, the computer found each of the confidence intervals for us. I'd like us to calculate the midpoint and the margin of error and the width for each confidence interval. Now, one way we can think of those numbers in the confidence interval is as low and high. So what we were calling the left end point is the low value of the interval, and the right end point is the high value. So the numbers in the interval should always go in order from smallest to largest, so the lower numbers on the left and the higher numbers on the right. Now, to compute the midpoint, we can you can look at your formula sheet, and you'll see a formula for observed statistic. And that's the midpoint of your interval, which in this case is a p hat because our variable is categorical. But there's also a formula there on the formula sheet that we can take the high value plus the low value and divide it by 2, and that will get us to the midpoint. So I'm going to do that for the 90% interval. I'm going to take the high value, 0.5564, plus the low value, 0.5045, and then divide that by 2. Again, I strongly recommend that you pause the video and try this for yourself. You should get, when you do that, 0.53045. And again, if you don't get that, it could be, the reason could be because you divided before you subtracted. So if your calculator has parentheses, you want to put parentheses around the addition. I think I said subtraction a minute ago. Sorry about that. I meant addition. Otherwise, you should do the addition and hit enter and get the answer, and then divide that answer by 2. But 0.53045 is the midpoint in this case. Then again, you should pause the video, find the midpoint for each of the other confidence intervals by adding the 2 endpoints and then dividing that by 2. In the case of the 95% interval, you should get 0.5305. In the case of the 99% interval, you should once again get 0.53045. And I just want you to notice that these are almost the same as the statistic p-hat of 0.53. The reason why they're a little bit different is because there's some rounding error, but basically the midpoint of the interval is our statistic, which in this case is 0.53. Then, if you look again at your formula sheet, there is a formula for the margin of error that is high minus low. So I'll do a color scheme here. High minus low divided by 2. So if you compare midpoint to margin of error, compare those two formulas, the midpoint you take the high plus the low and divide by 2. The margin of error you take the high minus the low and divide by 2. So again, I'll demonstrate this for the 90% interval. We take the high value, 0.5564, minus the low value, 0.5045, and then divide that by 2. So make sure you complete the subtraction before you do the division. And when you do that, you should get 0.02595. And that is our margin of error. Then again, pause the video and try it for each of the other confidence levels. Take the high value minus the low value and then divide by 2. You should get 0.0309 for the 95% interval, and you should get 0.04065 for the 99% interval. And again, if you're not able to get these numbers, let me know and we'll figure out what the problem is and we'll correct it. So note to self, the 0.0309 is similar to the 0.0316 that we had found when we were on our way down to calculating the confidence interval. There's again a little bit of rounding error, but the margin of error comes out as we work our way down, and we'll see that in the next example as well. Then let's look at the width of the interval, which is not on your formula sheet, but we can get it by taking the high value minus the low value, or we can get it by taking the margin of error and multiplying that by 2. So you can do it either way. In the case of the 90% confidence interval, if I take the high value, 0.5564, minus the low value, 0.5045, when I do that subtraction, I get 0.0519. So that is the value of the width. Or if I take the 0.02595 margin of error that I calculated and multiply that by 2, I get the exact same thing, 0.0519. So that is the width for the 90% interval. Again, I strongly recommend that you pause the video and calculate the width for the 95% and the 99% intervals. In the case of the 95% interval, you should get 0.0618. In the case of the 99% interval, you should get 0.0813. So what we want to do now, as it said in the directions, compare the intervals. And specifically, we want to note that, let's see, I don't have a lot of space wherever I am. But one thing is the midpoints stays the same. Again, there's a tiny little bit of rounding error, but when you compare each of the midpoints, it doesn't really matter what the confidence level is. I keep getting 0.53 for my midpoint. On the other hand, my margins of errors and my widths are going up. So I'm going to write that here. As the confidence level goes up from 90% to 95% to 99%, the margin of error keeps going up, and the width of the confidence interval also goes up. So the margin of error and the width of the confidence interval increase as the confidence level increases. So as you read across the margin of error row, you see that orange numbers going up as we move from left to right. When you look at the bottom row, the width row, the numbers in green are getting bigger as we move from left to right. So as the confidence level increases, so does the margin of error, and therefore so does the width. But the confidence level changing has no effect on the midpoint of the interval. That stays the same, and it's the value of the statistic, regardless of the confidence level that we use to create the interval.